Good evening, everyone. How are you guys doing? Thank you for reminding me to log on. I've been working on my PhD research and completely lost track of time, so sorry about that. So tonight's session is open for you guys. So yesterday we went through the memo of the mock exam. I gave you a few hints. Are there anything specific you guys are interested in? Any specific questions you would like answered? The structure of the sun. So, what do you mean, the structure of the sun? So, how in detail? So, for the composition of planets, don't need to know their compositions, don't need to know their history. So, for the planets, it's just general overview questions. So, for example, if I ask you, does Jupiter receive more energy from the sun, or does it radiate more energy from its own? You need to know it radiates more energy of its own, but you don't need to know the different layers. So for the sun, don't need to know specifically different layers. You just need to go, don't need to know different layers of the sun. You just need to know what convection is and the atmosphere. What is the photosphere? What is the chromosphere? Can we go through the steps of how terrestrial planets are formed? Yes, we can do that. So if you wanted to go through the memo, I've uploaded the video where I discussed the memo last night. So it's already up on YouTube. So if you just go through the announcements, um, just click on one of the links to the YouTube playlist and you'll find last night's lecture recording there. And there I discussed the memo, and there you can get all the answers. So for the terrestrial planets, that is actually quite easy to go through it. Let me see if I can quickly find the lecture slides for that so I can show you. I'm just finding the slides quickly to upload for terrestrial planet. So do you have a recording going through the mock semester test memo as well? Yes, I do. So just go through the playlist. Both are there. I'm just looking quickly for that slides again. For the 4 stages, Mars, Mercury. No, it's not this lecture slide. Think is number 15. Let me open up number 15 on my slide. Yes, the origins of the solar system. That is exactly what we want. So I'm just uploading it. Share files. Okay, it's busy converting. Age of the solar system. Let me just look for the correct slides. Let me quickly find it. Okay, it has uploaded. Let me open it up. So let's start with how it is. So let's start out with the Big Bang. So brief overview of the Big Bang. So the only thing you need to know about the Big Bang is that it happened everywhere at the same time, all at once, around about 13.8 billion years ago. If you look at the geometry of the universe does not have a center. So I know that's a bit mind-boggling, but we discovered that quite in depthly in class. So the only thing you need to know about the Big Bang is it happened 13.8 billion years ago. It happened at once all around us, and the universe does not have a center. And from the Big Bang, everything evolved to where we are today. And what evidence do we have for the Big Bang? So there are actually quite a few things. So the most important piece of evidence is the cosmic microwave background radiation. So if you look at your radio or old analog TV and a radio, that sound you hear between different radio stations, and it's snowflake effect. That is the cosmic microwave background radiation that we are still picking up. And doesn't matter where in the sky we point telescopes, we find that. So that's the one thing. The other piece of evidence is redshift. Everything in the universe is redshifting, or redshifted, let me get my English correct, which means everything is moving away from one another, which means the universe is expanding. So those are the two most important aspects of what evidence do we have for Big Bang. Is the cosmic microwave background radiation, and everything is redshifted and moving away from one another. And then when we look at the 4 stages of a terrestrial planet, let me just quickly find that slide, or the correct slide we discussed this, or slides. It's from slide 68. Let me just see if I can get to it quicker. So if you go through this slide to the end, this is where we discuss how planets are formed, but also more precisely how protoplanets are formed. So when we look at the different stages of how these terrestrial planets formed, the first stage is differentiation, meaning more heavier material went to the center of the planet, to its core, and the lighter material stacked up on top of it. So it means it differentiated. So take Earth, for example. We have an iron core. Above the iron core, we have magma with more heavier elements. And then on top of everything floats the crustal plates, and on top of the crustal plates is the continent. So the first thing is differentiation. The second step is cratering. So while after everything is differentiated, and while the planet is still forming, there's a lot of impact craters on those planets. But most of those craters has been filled up in the process, which is the third stage, which is flooding, due to seismic activity. So most of the craters has been covered up. And then lastly, once the flooding stage has stopped, we have slow surface erosion, which is the fourth step. And the slow surface erosion is what formed the surface of the planets as how we see them today. So the four stages again: one is differentiation, two is cratering, three is flooding, four is surface erosion. So if you go through just this lecture slide, all the details are in there, but that is the short and sweet. It's a pleasure. Do you guys have any other questions or something in the chat that I perhaps missed? Okay, the differences between a meteor versus a meteorite versus a meteoroid. So we talked about that in class as well. Let me see if I can quickly find a slide where we talked about this. It's not the outer solar system. Let me see if I can quickly find a slide with the definitions on it. Just quickly looking for the slide. So it is in lecture slide 19. So meet composition of meteorites. Come on. So the first thing is, if we look at lecture slide 19, slide number 10, you find the different definitions. So let's start from the way back. So the first thing is, if it is a meteorite with a T, so ends with I-T-E, meteorite, that means it has hit Earth's surface. You understand? Does that make sense? Then, what is it called when it's traveling through the atmosphere? When it's traveling through the atmosphere, it is a meteor. And if it's traveling in space, it is a meteoroid. Does that answer your question? Awesome. So question, is it possible to say what is important in the last lecture slide except the Drake equation? So in the last lecture slide, the most important thing there is the Drake equation. The other thing is extinction events. So if I ask you what caused the dinosaurs to be extinct, please do not say the impact of an asteroid. It's not an impact that killed them, but the effects of the asteroid, and we talked about it in last night's class. So again, the impact of the asteroid knocked up a lot of dust in the atmosphere. The dust blocked out the sunlight, causing a cosmic winter. With a cosmic winter, there's no more photosynthesis for plants. So that means herbivores died. When herbivores died, the carnivores died. That means starvation. And also due to temperature. And that is how the dinosaurs died out, not because of the impact itself, but the secondary effects. So that's the only thing we need to know. And also from the last chapter, if I ask you what is the definition of an exoplanet, you should know what is an exoplanet. Or if I talk about an exoplanet, what is a exoplanet? And then how much of the history should we know? What do you mean history in overall, with all the work, or specific aspect of the work? So what do you mean with history? So the one thing that I can tell you about history is it's not a history of dates or anything. History is just background information. Anything where history is important is if I say, for example, what a Copernicus overthrow, then you need to know and think about the heliocentric universe and how that fits in. But no, I'm not going to ask any history questions directly. It's a pleasure. So do you guys have any other questions? Anything else I can help with? So yes, could you list issues in astronomy that are yet to be solved? Yes, there are a few of them. So the one thing is, what is dark matter? Second issue is, what is dark energy? Third issue is, perhaps, what is the mass of a neutrino? Another issue is, are there other life out there in the universe besides us humans? That's speaking about intelligent life. Those are few outstanding issues. Another one is, what happens with the physics inside a black hole? That we do not know. The other one is, what happened before the Big Bang? We do not know. So those are all outstanding issues in astronomy. It was a question as Mr. One, why are summer days warmer than winter days? So that is surprisingly a question the majority of the class got wrong. So why winter is colder than summer has nothing to do with the orbit of Earth around the sun. And that has absolutely nothing to do with the distance of Earth and the sun. The only thing it has to do with is the angle at which Earth is tilted towards the sun. So that rough 21 degrees tilt. So when it is summer in the northern hemisphere, in the southern hemisphere, so here in South Africa, when it's summer, due to the tilt points the southern hemisphere more directly towards the sun. That means more sunlight can reach Earth, and also due to that tilt, it causes days to be longer. So that as you have more direct sunlight and more time for the Earth to heat up. In the winter, it's the opposite. So with the angle, the hemisphere is then pointed away from the sun, meaning you are receiving less direct sunlight and shorter daytime. So that means less energy and less time for the ground to heat up. And that's it. So what would be the most important equations for tomorrow? We talked about that in yesterday's class as well. So yesterday you asked how Earth avoided greenhouse effect. I do not understand that, sir. Could you please explain it? Okay, so two things before going to that. I went through the formula sheet yesterday as well, and I gave hints in the memo for the mock exam of important equations. So just go through those equations again. So yesterday you asked how Earth avoided greenhouse effect. I do not understand it, sir. Could you please explain? Okay, so let's go through that as well. Let's just get my bearings straight. So one thing we can do is, if we look at Venus, Venus consists out of one big greenhouse effect. So how did Earth avoid a fate that the atmosphere of Earth did not have a runaway greenhouse effect such as Venus? And there are two major factors for it. So the first one is we have liquid water on Earth, aka the oceans. And water is very good in absorbing CO2. So the water absorbed the majority of the CO2, stopping that we didn't have a runaway greenhouse. And then the second factor is Earth is a bit further away from the sun than Venus. And that also helps us that we don't have a runaway greenhouse effect. So the liquid water to absorb CO2 and the distance from the sun, and that's it. It's a pleasure. Do you guys have any other questions? Any tips or hints for tomorrow? I gave all the hints and tips that I could in yesterday's recap class. So if you just go on to YouTube and you look at the recording of yesterday, then all the hints and tips are in there. Okay, so can we speak about the magnetic fields? Okay, what do you need to know or want to learn about magnetic fields? Earth's magnetic field, Sun's magnetic field. Anything specific? So if you just want, we've been speaking about the greenhouse effect. So the magnetic field has nothing to do with the greenhouse effect. So the only thing the magnetic field is important. It protects us from cosmic rays from the sun. So remember, the sun emits radiation at all wavelengths and all frequencies. So that means we're getting gamma rays, X-rays, ultraviolet, infrared, visible light, everything from the sun. So the Earth's magnetic field protects us from the high energy particles such as X-rays and gamma rays. The only thing from the sun that penetrates through that's not stopped by the electromagnetic field is infrared and ultraviolet. So if you're outside, if you get sunburn, the sunburn is due to the ultraviolet radiation from the sun, not the infrared. So that is why if you're driving in a car, you are not really getting sunburned because your glass windows and your glass windshield blocks ultraviolet radiation. But the infrared is still getting through. That's why you can still feel the heat of the sun because the heat is traveling through in infrared. But the sunburn, it's ultraviolet. So another semester test one question. So as a white dwarf cools, its radius will not change because that is a very good question, but a radius will not change because it's made out of degenerate electrons. And because it's just cooling, it's not changing. So if you want the specific. Let me see if I can find a specific answer for that question. Let me quickly find it. Why can't I open that? That is weird. So let me just see if I can quickly find that. Which question? Okay, so as a white dwarf cools, its radius will not change because it's made out of degenerate electrons. Pressure does not depend on temperature for white dwarf because the electrons are degenerate. Since it is degenerate matter, it doesn't matter how much pressure or temperature you add to it, it will remain degenerate, and therefore it will not change. Does that answer your question? So are X-ray telescopes placed in the Earth's atmosphere or are they ground-based? They are placed in space and also ground-based. So we talked about this in one of our lectures as well. If you want to do X-ray observing, there's a few important factors. So if you want an X-ray telescope based on the ground, you need to place that telescope in places that is very high and very dry, because if it's, one thing is X-rays gets absorbed by water vapor. So you want to place those telescopes on Earth where water vapor won't be a problem. So that is on mountain tops that are very, very high, so above the water vapor level in the atmosphere. And then secondly, in deserts, so that there's no water vapor. So if you want to just, you'll see on announcements, I've posted links to the video playlist quite regularly. So just go through that. And then a second reason is it's easier. So sometimes you can place an X-ray telescope in orbit around Earth. Then you can observe X-rays without worrying about water vapor. So they can be in orbit and they can be based on the ground. So I hope that helps. It's a pleasure. So it seems like through the semester, a lot of you actually missed my recordings, and I made a lot of announcements for it in any case. So let me see if I can quickly find that link. Here is a link. Let me give it to you guys. Should know all the important astronomy discoveries, pattern recognition, Herschel's map? No, not in that detail. So how extensive must our knowledge be about the history of the universe? Should we just know about the Big Bang, Dark Ages, first light, and today, or should we also know about the first few? No, you don't need to know anything about that in detail. You just need an overview of the Big Bang. You guys are worrying, looking at the finer detail. I'm not going to ask the finer detail. Do you guys have any other questions? So you should, the HR, I told you, the HR diagram are probably the most important diagram in astronomy. So if I ask you where are white dwarfs located, you should know it's a bottom left corner. If I ask you where are supergiants located, you should know it's the top right corner. So yes, you should know an overview of the HR diagram and where what is located. Pleasure. Any other questions? So the video of tonight's lecture, I will post it directly after this class. So may you quickly run through Kepler's three laws. So that is something you guys should know as well. But let me quickly find them in the lecture slides. It was one of the early slides. Telescopes. Let me quickly see if I can get them. Yes, so that's in lecture 3, slide 29. So let me just upload it. It's just busy converting. Okay, still busy converting. So that I discussed in yesterday's lecture as well. So if you just go through yesterday's lecture recording, you gave explanation on that as well. Okay, it has uploaded. So slide number 29. It is this slide over here. So these three definitions, you should know them by heart. So if I ask you what is Kepler's second law, for example, you should know what his second law is and explain how it works. So the first law is the orbits of the planets are ellipses with the sun at one focus. The second law is a line from a planet to the sun sweeps over equal areas in equal intervals of time. And thirdly, I've seen this in the semester test as well. If you write down the third law, don't just write down the formula, you will get 0. I want you to write it out and in words and then give the formula. So thirdly, a planet's orbital period squared is proportional to its average distance from the sun cubed. So what this means is with Kepler's first law. The orbit is an ellipse with the sun at one focus. So there will be a focus on this side and a focus on that side. So the sun will be at one focus. But in orbital mechanics, everything is basically ellipse. So whatever it's orbiting, everything will be at one focus. The second law is, if we look at an object orbiting around the sun, due to the distance, its speed will in certain places be faster and in certain places be shorter. But this area A1, when it's closer to the sun, distance of 1 month, is exactly the same as the area A2. That is the overview of Kepler's second law. And in Kepler's third law is, just the squares of the orbital periods of the planets are directly proportional to the cubes of the semi-major axis. So what that means is, we basically use this formula over here, or if you write it and be in better notation, it is this formula over here. And basically what that means is, from that formula, we can calculate the orbital period and the distance from that formula. So if you have the one, you can calculate the other one. And that's the overview of Kepler's three laws. Short and sweet. Do you guys have any other questions? Anything else you guys need help with? Can everyone still hear me? Awesome. So, can you please go over comparing temperatures of stars? What do you mean with comparing temperatures of stars? Which formula would we use if we are given the temperatures of two stars and want to know out how much energy one radiates compared to the other? Okay, so I've actually done in last night's lecture recording, went over this quite thoroughly when answering the questions. But if you basically want to know what's going on, so let me just find a formula sheet. Where did I save the formula sheet? Depending on how the question is framed and asked, it will either be this formula right here or this formula right here. So to get an understanding, go through the chapters when we've done reasoning with numbers examples and look exactly at the one that we've done on black body radiation. Pleasure. Do you guys have any other questions? Would it be possible you've posted a memo for our semester? Sir, unfortunately not. If you want to go through the memo, I've discussed the memo for the semester test in class. So if you missed that class, unfortunately, that's a loss for you. So one thing I've realized throughout the semester, not many people attended my classes, which I am disappointed in. So if you missed that, sorry, you've missed that. That's one of my ways to keep or force people to come to class. So unfortunately, if you missed that period, you've missed that period. So yes, I've talked about it and I've fixed that and I have correlated that mistake as well. Which question is that? And we can discuss it. Question 1 for the semester test. Okay, I'm going to open it up. Question 1 of the multiple choice. Okay, let me just quickly find it. The average distance from Mars to the Sun, no mistake. Correct answer is C. I know that was a mistake and I've correlated that one in the memo and I've fixed that throughout for everyone. In class, I told you I would fix that one for everyone and compensate the marks for that one, and I did. Any other questions? Where did you find that formula? Oh, on a formula sheet. This one right here. No, that's not a error. I got that directly from the textbook, but yes, that is a error over there. So it's m to the power 3.5. So that's just a typo. That is L equals m to the power 3.5. Pleasure. Any other questions? So that's already been fixed, the question 1 error. I fixed it throughout the board for everyone. So please relax about that. Yes. Any other questions? So if you have no further questions, you are more than welcome to log off. Then I will see everyone tomorrow at the exam venue. It will go well. It's quite a fair exam. If you just go through what I've said during the semester, if you attended my classes, you know I gave a lot of hints and tips. In yesterday's lecture recording, I also gave a lot of hints and tips. Otherwise, it's quite fair. If you know the work, not by heart, just understand the work, you will do fine. Good luck with your last bit of preparations, and then I will see everyone tomorrow. It is only a pleasure.